Hello, welcome to Edexcel demola, and today's lesson we're covering qualitative analysis. It's a very high yield topic, comes up almost every single year, so we're going to be talking about tests for anions and cations. No time to waste, let's get into it.
Okay, so we're going to start with anions, and these are your negatively charged ions. So, three main tests we need to know about: halides, carbonates, and sulfates. Now, for halides, thankfully we only need to focus on chloride, bromide, and iodide. So, we are going to use AQA silver nitrate. Now, very important, just remember your reagents, yeah? And also remember your equations, it does come up quite a bit. Normally the ionic one. So I'll draw the ionic equation, for example, with chloride here. So we have chloride ion plus silver ion, and that goes to silver chloride. Now, all of these reactions are precipitation reactions. So we're forming a solid precipitate at the end of it. Now, the color of this precipitate is the qualitative part of this. So silver chloride is white, silver bromide is cream, silver iodide is yellow. And remembering those colors is so important. What I kind of see it as is like a scale of it getting more colored. So like the color is like more with iodide as you go down the group, and then it's white with chlorine when we're up. Yeah? Cool. If you see it on a paper, you can tell the difference between these colors. However, in a test tube, it is a bit different and they can look a bit similar. So we have something else that we can do to like further confirm what we're seeing. Now, with chloride, well, okay, what I'm going to say is we're adding ammonia. Yeah? Cool. So, dilute ammonia will dissolve silver chloride, meaning that white precipitate is now going to become a colorless solution. Cool. If you now have concentrated ammonia, so we've stepped it up to concentrated ammonia, silver bromide can now dissolve. Silver chloride will also dissolve, but the way that we can tell the difference is that the silver bromide would not have dissolved in dilute ammonia. So you can see that dilute ammonia, silver chloride, concentrated silver bromide. And then silver iodide just does not dissolve in ammonia. So that's how you can see the difference. If you had concentrated ammonia, you'll see your cream precipitates and your white precipitates disappear, but the yellow one won't. If it's dilute ammonia, only the white one will disappear. Everything else will stay. Cool, next test, carbonates. So this is your CO3 minus ion. Now, it's kind of like a standard reaction, metal carbonate plus acid. You're going to form your salt, you're going to form carbon dioxide and water. I've just written out the ionic equation, yeah? So carbonate ion plus protons goes to carbon dioxide and water. Now, whenever you have a gas produced in a solution, you should be able to observe bubbling, yeah? So that's the main thing. We're observing bubbling, that tells us that that was carbonate ions present. But what if we really wanted to confirm, like, it should be the carbonate, sure, but what if it was hydrogen, for example? Yeah? What we can do is we can bubble that gas through lime water. Now, lime water, very important to remember, calcium hydroxide. You don't want to be the person that doesn't know when it comes to exam day. Lime water is calcium hydroxide. And what happens is you'll form a precipitate which happens to be calcium carbonate. Yeah? And that is that cloudy appearance you're seeing. It's calcium carbonate forming. Cool. Next test, sulfates. This one, I've added a bit about adding the dilute hydrochloric acid just as an add-on if you're really trying to push. But really, in the exam, what they want to see is that you know that your reagent is barium chloride. So you're adding a few drops of barium chloride, and what's happening? Your barium ion reacts to the sulfate ion, forming a white precipitate of barium sulfate. So those are your tests, yeah? So we should know silver nitrate for halides, we should know dilute hydrochloric acid for carbonates, and barium chloride for the sulfates. Okay, so it's question time. We got a multiple choice one to start off with, and then you've got these two which are a bit longer. So I would always say like pause the video so that you can have a read of the questions. Yeah, that's about it. So yeah, have a read of those questions, have a go, and then we'll go into the answer. Okay, and this one shouldn't take too long, but for cations, right now in module 3, the only thing we're worried about is ammonium. Yeah, so your ammonium NH4 plus. Now, very important distinction that a lot of people forget. You are reacting it with warm aqueous sodium hydroxide. Yeah? And when you react your ammonium ions with your hydroxide ions, you form your ammonia gas. Cool. And you also form water. Now, important point. Like I said, if you form a gas in a solution, you should see bubbling, right? But ammonia is so soluble in water. So it's going to be quite hard to see the bubbles because it's already going to be starting to dissolve into an aqueous solution. Cool. So, what we can also see is that ammonia gas is going to be released and will cause, again, a damp red litmus paper to sun blue. I always think about it like ammonia is an alkaline gas. So it's going to be forming like your more alkaline colors on the universal indicator, so like your blues and your purples and stuff. Cool. I've got a diagram here that I got online. So Warm hydrochloric acid, that's why we've got the Bunsen burner. So warm sodium hydroxide, sorry, not hydrochloric acid, warm sodium hydroxide. Cool. And then you're reacting with ammonium ions, you form the gas, and then that damp red litmus paper is turning blue, as you can see. And that's your test for ammonium. Not too much in excess to know from that, but remember the equation it is really important. Okay, I'm going to quickly show you the answers, but we're going to more focus on how do we get there, right? So 5D7, you can see here it's sodium bromide and calcium chloride. Here, we should know about ionic compounds in solid and aqueous solutions, and then also sulfate. Yep, cool. Let's quickly go through this. So just to confirm this, we had a carbonate in the first test tube, we had silver nitrate in the other one. So hydrochloric acid, obviously, it's an acid, and also it contains chloride ions. So because it's an acid with a carbonate, it's going to form that carbon dioxide gas, you see effervescence. And then you're going to form a precipitate, the white one, because you're going to form AgCl in this one. So we're going to get a precipitate. The only thing that allows us to have both is D. Now, let's look at this question. So first things first, I do know that in this question, you do need to make some assumptions, right? However, what I can say is, given this line here about the molar masses being in the range of 100 to 115, I can tell this is not going to be iodide. Iodide has an MR of about 127, so it can't be iodide. If we look at this one, say that our metal is Y, for example, B is going to be YX, X being the halide, and then this is going to be YX2. So because of that, bromine has a MR of about 79. So I can say bromine is not going to be here. So that's not going to be the bromide. That means that, I don't know what's happening now. There's probably going to be a chloride, and that's completely going to be a bromide. Yeah? Cool. So what we can now do is take away the MR of your bromine. Yeah, we can do that. So say this is like 115, take away about 79. Yeah, 115 take 79 gives you an answer of 36. So I'm thinking, what is a compound that has an MR of about 36 in group 1? So you look down group 1 and your answer would probably be sodium. Yeah, though sodium I believe is 23, but it would probably get you in the range if you went a bit lower. So like say if you went on 100, take away to 79, you get 21. So you're in the range between 21 to 36, and probably also do that. And then you can see within that range, you're going to have sodium. Yeah. Same thing that we're going to do for compound C. I know that chloride is going to be 70 if you have two of them. So it's 35.5 times 2, 70, or 71. So what we can do is pretty much same thing. Take 71 here, and then you can do 100, take 71 as well. And then when you do those answers, you do get a range again. So if we do 115, take away 71, you're going to get 44. And then if you get 100, take 71, you're going to get 29. And our group 2 element that's in between that range happens to be calcium. So you can see how we got sodium bromide and calcium chloride. Cool. In terms of the other stuff to do with this question, here we can kind of just go on now. So you should know test for halide, silver nitrate, white precipitate, cream precipitate, yellow. Remember, we haven't kind of gotten everything yet at that point, so you're listing all the results. Do one of the equations, happy days, and then yeah, we've gone through the reasoning now. And then also this one, I would expect you to know as well. Yeah, barium chloride is an ionic compound. Solid state won't conduct. In the aqueous state it will, and that's because of the mobility of the ions. And then you can use it for the test for sulfate ions and the forms of white precipitate. Always just good to know. And that is how I would explain this question. Okay, hoping that was a nice send-off for 3.1. So, in terms of the A-star tips, what to do, reagents, conditions, I cannot emphasize how important this is. Not only for module 3, but when you get into organic chemistry as well, very important to be able to know reagents and conditions. And then the order you're doing tests is really important. So we talked about the dilute ammonia to concentrated ammonia. That's something that can come up as well. For example, barium chloride one, if you've done that before testing for a halide, you've introduced chlorine ions, so you're going to affect the results. Just think about stuff like that. What do you not do for getting the results? Guys, I promise you that this is not too much to remember. Yeah, so just make sure that you can memorize the reagents, the results. Really, really important. And then ionic equations, make sure that you know how to write an ionic equation. It's something that you will keep on needing to do. So it's better to have that skill locked in now whilst you're in year 12. Or if you are reviewing this in year 13, very important to have that skill locked down. So, hope that video was helpful in terms of learning about qualitative analysis. If you found it useful, like, please, and subscribe to the channel, please. We've also got comments below. So any questions, just comment. I'll do my best to address them. We've also got our TikTok and the Instagram, both at demola. Links will be in the description below, and I'll catch you guys in the next one. Bye for now.